Good afternoon. Today we will solve some problems of curvilinear motion. So in the last class, we have essentially learned what are the important concepts or the equations or in a totality, what do you mean by curvilinear motion? That's what we more discussed, and we derived some important relationship, and we were able to represent our motion parameters, which are position vector, velocity vector, acceleration vector, into two representation. One is rectangular component representation or normal and tangential component representation. And we also have seen what is the relation between these two representation. So that's what with which we ended with the last lecture. Today we will solve some problems so that we will confirm our understanding of those things what we discussed in the last class. So let me share my presentation slide. I hope all of you are able to see the screen. And in the last class, essentially that we were looking at what is the relationship between rectangular components and the normal and tangential component relationship. See, you have here A cross V can be determined by this determinant, or you can also represent A cross V in terms of its normal and tangential component across V vector. So we were able to prove this relationship, which is very useful relationship in relating rectangular components with the normal and tangential component. So what is this essentially? V cube by rho is what? V squared by rho is An. So An into V is what is the magnitude of An into the magnitude of velocity. If I multiply, what do I get is this determinant value. So that is quite useful relationship. And so this is the fourth lecture on dynamics. So in the very first lecture we looked at importantly what do you mean by kinematics and what do you mean by kinetics, and what is particle kinematics, and what is rigid body kinematics and rigid body kinetics in overview. And in lecture number 34 we were essentially understood the definition of motion parameters. There can be primary motion curves and secondary motion curves. As we have 6 motion equation, kinematic equations, 3 primary motion equations which are represented as function of time, and 3 secondary motion curves are corresponding to 3 secondary motion equations. So we solved some problems, interesting problems like this, and in that we understood what do you mean by displacement and distance traveled by the rectilinear motion of a particle. And you have also understood an important point called the point of reversal. When velocity is 0 for a rectilinear motion given by a continuous equation like this case, what we discussed as a homework problem, we will not consider that the vehicle stopped at that point. That is the point of reversal. So you will have your motion of a particle starts from 20 meters, go in one direction, then velocity 0 reversing, and then again velocity 0 is again reversing its path, and so on. So that process we were able to find in 9 seconds what is the motion executed by a particle whose acceleration relationship is given by 80 by 3 minus 8 meter per second square. So we were able to plot the motion curves, and hence we are also able to solve this problem. We could find out total distance traveled in 9 seconds. So this is another rectilinear motion, comes under the category of translation. In the last class we have looked at what do you mean by curvilinear motion. So again, curvilinear motion is translatory motion, wherein you see that velocity can be constant, but still it is an accelerated body, because to maintain the direction, an important component of acceleration along its radius of curvature has to exist. Generally, it can go in direction in the curved path. So with that basis, we just started understanding curvilinear motion and its translation. And then we were able to represent the motion parameters in a rectangular coordinate system. And also we look at that motion can be represented also in a normal and tangential coordinate system. Further, what is the relationship between radius of curvature? How can I express if I know the equation of the path, or if I know the motion parameter, velocity vector, and acceleration vector? At any position x comma y, I would be able to find out my radius of curvature. That's what we have seen. And then we'll be ending our lecture with this. That was in the last lecture. And today I'm going to take up some problem to confirm this curvilinear motion. So this is lecture number 56. And today's date is 19th. Let's look at the problem. A particle travels on a curved path. A particle. So word particle, you should not misunderstand this tiny particle. That's very important ideology. That's what we are discussing. A particle means a rigid body, physical geometry is neglected. Travels a curved path given by x squared by 4 minus 2y squared equals 24. If x component is the x component, someone is to mute your so mute all in case you have a doubt. Please unmute and speak. If the x component of velocity is Vx given by 6 meters per second, 6 meters per second, and remains constant, this remains and remains constant, determine the particle's velocity and acceleration at x equals 16 meters. That's the question. So now you can see that since the given equation is a curved path, so x squared by 4 minus 2y squared by 1 and equals 24. So this represents a path equation because you do not have explicit appearance of variation of x and y as function of time here. Right? So this is your path equation. So on this path, you know that x component of velocity Vx is constant. So when you are given this statement Vx is constant, immediately you know that Ax equals 0. What is Vx? It is the velocity component along x direction, which you already seen. That's remains constant. So the acceleration in x direction, horizontal direction, is 0. And determine now particle velocity and acceleration at x is equal to 16 meters. So y is equal to function of x is what is my path equation. I'm not going to write y as function of x and make it my equation and differentiating it. I'm going to just use the same given form of the path equation. It's x squared by 4 minus 2y square is equal to 24. So I'm going to differentiate this now, this path equation. So this is a path equation. You could represent, if you are interested exactly to get your path variation or plot. So y is equal to f of x, you can write, right? But I'm taking as it is in the given form and I'm differentiating this equation because I know x and y are function of time. So if I do that, I will have now 1 by 4 as constant here. So this is going to be 2x into dx by dt minus 2. I'm differentiating with respect to time. Why? Because in this path equation, x is function of time and y is also function of time. So 2 into 2y into dy by dt equals 0. 24 on the side constant. So now this further can be again done as 1 by 2. So this uv differential. So x into, so what is this? Dx by dt is vx. So that's going to be ax plus vx into vx, because this dx by dt, that's vx, minus 4 into y into ay, because d squared y by dt squared is ay, plus dy by dt into this, so it's going to be vy square. Vy square. Right? So that's going to be equal to 0. So this is equation 1 and this is equation 2. So now equation 1, what is that I have? Let me rewrite this equation 1 as 1 by 2 x vx minus 4 y vy equals 0. So in this now I know what is this asked. At x is equal to 16 meters, I have to get my velocity and acceleration vector. That's a simple problem. So I can substitute this x in this, and vx is also given, which is constant. And I know what is y when x is equal to 16. I can find out from the path equation. And only unknown is vy. So I can get from this equation what is vy by substituting rest of the values. Vy, well, that's unknown. So it is 1 by 2 into x 16 into 6 minus 4 into, what is y correspondingly at x is equal to 16, what is y? It is 16 square by 4 minus 2y squared is equal to 24. That solves for y equals, what is y value? 4.472 meters. 4.472 meters. So when x is equal to 16, y value is this. So I will substitute that here now. That's 4.472 into vy equals 0. That solves for vy equals 2.683 meter per second. So I get here this is positive value, so its direction is in this vertical direction. Direction is this velocity. So Vx direction is what? To the horizontal. Vx 6 meters per second to the horizontal. So I would be able to get my velocity magnitude and its vector form. So what is my velocity vector? Velocity vector at x equals 16 meters would be Vxi plus Vyj. That's Vx is 6i plus 2.683 j. So what is its magnitude and direction can be easily found out by means of taking its modulus value. Right? So what is its direction? I think I can't solve that one. So its magnitude now. So its magnitude would be under root of 6 square plus 2.683 square, which is equal to 6.573 meter per second. And its direction can be found out to the horizontal by having theta tan inverse of Vy by Vx. So substituting that, you will get the direction, which is direction to horizontal. So this is how you can get what is your velocity vector. And what is your acceleration vector now? Look at the second equation, wherein you have now Ax in the problem is 0, so this term is going to be 0. So you have Vx square by 2 minus Ay plus Vy square. So Vy is just we know, now y we know, Ay only is unknown and Ax is 0, so this term goes off. Vx is known constant and I would be able to get what is Ay, that is what is my acceleration vector. So acceleration vector is in vertical direction. So that I can find out easily now, right? So from the second equation, that is 0.5 into xax, I'm rewriting the equation, vx square minus 4 into 4ay, sorry, y into ay plus vy square, that's equal to 0. That's my second equation. So this goes 0. So it's going to be 0.5 into Vx is 6 square minus 4 into Yay. So Y value is found out 4.472 into Ay was just found out. Ay value, oh sorry, Ay value we need to find out. So Ay plus Vy is just now we have found out, that's 2.683 square equals 0. So this solves for this Ay. So you get Ay value from this is equal to minus 0.603 meter per second square. So it is minus 0.603 J. What is Ay vector? Right? So you are able to find out what is the magnitude and direction of acceleration and velocity at that position. So this is how you can just solve the problem. It's a simple problem. It is not for 10 marks. It may be for some 3 or 4 marks. So one can just substitute and solve. So now let us look at